Good morning, everybody. We want to get started on time. I'm really excited that we have this first session now on requirements and elicitation. And we have 6 speakers, so we've got a lot to get through. I really encourage you to think of your questions as the presenters give their presentation, and there'll be time for 1 or 2 questions after each one. So our first speaker today is going to, I'll let him introduce his own title, and so I don't waste time with it, and let's go. Thank you.
Thank you. Hello, everyone. My name is Saad from the University of Luxembourg, and on behalf of my co-authors, I will present our paper, AI-based question answering for analyzing natural language requirements. So, during the manual review of long requirement documents, the analyst focus scope is limited to the passage or the page they are reading. And this can cause the analyst to miss related and interconnecting requirements that can be found in different parts of the document or in other documents such as domain knowledge. But with the current AI technologies, we hypothesize that the analyst will obtain a comprehensive overview through a question answering assistance. For example, the analyst can ask questions which can arise during manual review sessions, and the answers of these questions can reveal quality issues such as incompleteness and inconsistencies. A question answering assistance can extract distance requirements and highlight relevant text segments. And in this example, the expression regular basis in the extracted requirements is not clear. Moreover, retrieving multiple requirements on the same topic can help the analyst to find inconsistency issues. And in this example, the 2 extracted requirements are inconsistent because the second requirement violates the exclusive usage that is specified in the first one. And sometimes answering the questions from an external knowledge is needed, and especially when they are missing information such as glossaries. And even when the analyst has domain knowledge, evoking this knowledge instantly is not always an easy task. And in this example, we use Wikipedia for extracting the wet mass definition, but such a definition can be extracted from any external knowledge. So far there is limited work on question answering in the context of RE. And there is no existing work that is focused on aiming or on providing assistance throughout question answering during requirements analysis sessions. And what exists focus mainly on requirements traceability and retrieving compliance-related information. And these techniques rely on information retrieval methods, while the NLP cutting-edge technologies, the advanced technologies, are underexploited in this case. And moreover, there is a lack of a good quality dataset that is tailored to requirements. So to address these limitations, we propose QAssist, which is an end-to-end framework that provides assistance with requirements analysis. We have explored natural language generation techniques to semi-automatically generate a question answering dataset that is tailored to requirements from different domains. Doing this, we proved that the data scarcity can be solved by these generation techniques. We empirically evaluated QAssist on the generated dataset using different state-of-the-art machine learning models, and it demonstrated a high accuracy, as I will show later in this presentation. So first, let's have a look at our approach. Given a question posed in natural language about some requirements in an RS, QAssist uses NLP to retrieve the relevant passage from the RS. We then retrieve relevant documents from the domain-specific knowledge, which can be generated automatically by crawling Wikipedia, for example. And the relevant documents are split into passages and ranked by the passage retriever. The top passages from both the RS and the external knowledge will be passed to a reader model to select and highlight the exact text segments that is answering the input question from each context. I will explain the steps in the next slide. So in the first step, we apply a simple NLP pipeline of tokenization and sentence splitting to split a given document into a list of passages. We respect a token limit. For example, 512 tokens is a popular limit for BERT large models. In the second step, we apply information retrieval techniques to select and rank the top passages to the input question from the set of passages that are coming from the RS. We experiment with 4 different information retrieval techniques. The famous TF-IDF, term frequency inverted document frequency, UCAPI BM25, which is an improved version of TF-IDF that is optimized for information retrieval. The Stilbert language model, which is trained to provide scores leading to identifying the relevant passages, re-ranking that, and the re-ranking that ranks the outputs of BM25 using mini-LM language model. In the third step, we use Wikidominer, which is a public tool that we have built. It automatically generates domain-specific knowledge from a given document by crawling Wikipedia. So first, it extracts relevant keywords from the input document. These keywords are used to query Wikipedia for matching articles. And then we also extract articles that belong to the same Wikipedia category. And the output articles form the final corpus. So in the fourth step, we have the document retrieval module that applies the same information retrieval techniques that are used in the passage retrieval step to select the most relevant document from the domain-specific corpus. The selected document is then split into passages and fed to the passage retrieval step to extract the relevant passages. And finally, once the relevant passage is identified, the answer extraction module applies machine reading comprehension language models that are trained to extract the exact answer from the relevant context. We use 6 language models that are readily fine-tuned for question answering. These models include Albert, BERT, Distilbert, Electra, Mini-LM, and Roberta. So to evaluate our approach, QAssist, we first created Requesta, which is a dataset that is tailored for requirements. And as we know, manually creating questions and answers is a time-consuming task. So we leverage the recent advances in generation models and generation language models to automatically generate question-answer pairs over 6 requirement specifications from 3 different domains. So we hired 2 external annotators, and they validated these question-answer pairs and provided new pairs. And in total, Requesta has 387 question-answer pairs, 45% of which are automatically generated. And this dataset is publicly available for academic use. So we defined 2 main research questions. For the first one, we wanted to find which AR model is best for retrieving the most relevant document and the text passages. We use as a metric recall at K, which measures whether the relevant document or passage was among the top K extracted documents or passages. So looking at the document retrieval, all our information retrieval models can identify the most relevant document in a corpus with a near-perfect recall. We select BM25 as the best model because of its efficiency. For the second part of this research question, passage retrieval is a more challenging task. On top, we see the results concerning the questions that are from the RF. On bottom, we have the questions from the domain-specific documents. So following this, the ranking method that combines BM25 with mini-LM has the best recall at 3 of 90%. Of course, we experimented with other K values and higher K values, but we found out that the K value of 3 provides the best trade-off between accuracy and the manual effort that is needed for reviewing these documents. For the second research question, we want to identify which question answering method is the best for extracting answers from the passages. We use 2 metrics, partial match, which is trivial, so we calculate the ratio of predicted answers that have an overlap with the correct answers. Semantic match, which calculates the ratio of the predicted answers that are semantically similar to the correct ones. So here we select Albert as the best performing model since it has the best average accuracy on both metrics. So to conclude, I have 4 takeaway messages. The first one is that we have proposed QAssist, our question answering framework that can assist with requirements analysis and help revealing multiple quality issues. The second one, we have tackled the data scarcity problem by using natural language generation with human validation. We proved that this can result in producing high-quality data sets. Also, our approach finds the relevance passage in the top 3 suggestions with a recall of around 90%. And the last one is that our framework, QAssist, is highly versatile as it is built using multiple pluggable components which can be replaced with updated recent models. Thank you for listening, and I'm ready for your questions.
Okay, thank you. Do we have any questions? Any questions? Yes.
Thank you very much. So I was wondering, because the descriptions that you start with can belong to the same domain, but you can potentially have very different systems, right? So would you still be having, if you're looking for a bare version of something and you're looking for something with all kinds of bells and whistles for the particular domain, will you be having the same type of suggestions to your answer? So, if you want something elaborate and something quite simple, I guess, you kind of expect different things, but I don't know, because you have the same corpus, would you be getting the same answers?
So the corpus is automatically generated using the domain of the document. So it changes depending on the domain. So in our pipeline, for each document, it detects the domain using these keywords, and then the corpus changes, and therefore the answers are changing as well. So they are not this.
Okay. So I guess maybe you will have a smaller corpus for a smaller kind of limited version.
But there are some details I didn't go into them. So we can increase the depth of this corpus. So depending on how much we can widen this corpus. So if we widen the search, we can go a little bit on the broader side, or not very specific.
So it's somehow a follow-up, but different. So at some point in your slides, right, you were showing, I think, for research question 1, different domain, you had different size corpus. And of course, not very much surprisingly, different result, because depending on how bigger it was. I was wondering if it's in your plan to study the correlation, to try to understand, I'm pretty sure there are also other factors, not just the number, but also the quality. But if you're trying to study what is the minimum you need to have a certain quality in your responses.
Yeah, that's a genuine point. Normally the corpus size would affect the results, especially when we don't have a lot of documents, and also it depends on the quality of the documents that are in the corpus, not only the size. So a detailed study can be conducted on this point.
Okay, just one last question. Have you thought about, if you're coming at this with a new domain and you're a software engineer, giving some kind of indication of how well it might be able to perform? So in other words, if I'm working in a very obscure domain that there's very little domain documents available, I might get answers back, but they're not going to be very good. Have you thought about kind of giving those kind of hints to software engineers, requirements and analysts?
Yeah, so that's true. It is heavily dependent on the domain corpus. In our pipeline, we have the automatically generated corpus, but also...
Do you want to just come over this side to finish answering?
Yeah,
we're going to have a switcheroo, sorry. Yeah.
But also so the engineers can provide the private or corporate domains or documents that can be used as these external domains. So
that's
the
the
answers
mouse.
can be
I lost
also
the mouse.
extracted from this focus.
Yeah, I know, that's what I want to do, but the mouse disappeared.
Thank you. Let's give some applause to our speaker.
Yeah, no, it's there. Yeah, it is.
It's the two screen.
Yeah, I know, I always do the same. Yeah, thanks. Interesting. Okay, so first of all, thank you for being here, listening to this presentation. This is a work on a manual elicitation technique, and specifically what we call App Store Inspired Requirements Elicitation. So the idea here is that when you want to expand and get a new idea for your product, you could browse the App Store to find, similar app and see if you can get some new inspiration. And this is actually something that is used in practice. There has been recently a study from Federica Staro group with many practitioners that shows that practitioners really use it. But if you look at the research we do on that, it's very limited. And so when we don't have much research on something, at the end of the day, what happens is that, how you can educate the new requirements analyst, or what works, what doesn't work. And so we decided to try to look into this problem a little more. And we ask ourselves two questions. So what do these practitioners do when they browse the App Store, right? Which are the strategies they are using? And also, what do they find difficult? What do they find easy, right? And to answer this question, we ran an empirical study with 58 graduate students enrolled in the master student in software engineering in my university. Now, I know now I say practitioner, and now these are students, right? But our master is offered in the evening and in an hybrid form. And our students almost always are professionals. So in fact, if we look at the demographic, 80% of the students actually have experience in industry, and among them, almost half have actually extreme experience. Now, the remaining 20% are what we call career changers, that are people that come from a complete different domain, and they don't like them particularly, and they say, you know what, I want to move into software engineering, and so they take some foundational class, and then they end up in the master. Still, though, somehow understand the real world, right? And so these are our participants. And this is a simplified version of what you will find in the paper to answer these two research questions. So forget about the very beginning, because we have to create the product, right? And we do it in classical way with interviews. But let's forget about this. This is another paper. You can read it in the proceeding of 2021. So imagine we have a product, we have a customer, and with our customer is the owner of a summer camp that are not camping, but are those places where you send your kids during summer when there is no school. And now he's happy, but he would like to be more competitive. And so we are asking our students or our analysts to get new ideas. And so their task here is to select at least 5 apps from the App Store, try to use them, look a little bit into the reviews. We didn't give them any tool, and we don't particularly care about all these. I mean, we do care, but not in this work, about all these research in mining app reviews, so they can do it wherever. And then we ask them, get new requirements out of it. Now, to answer the first research question, we use what they give us as output of this activity. That mainly is the list of the app, and then why they chose them, right? And then which are the features of the product they want to get out of it. Then we extracted this, the strategy they use in this description. At the end, we had 295 items, because each student had at least 5. And then we coded it we separated this into groups. We did open and close coding. And then at the end, we came out with this strategy code book. What did we find? So we found 11 strategies. And I don't want to enter in any of them because we have 12 minutes. And so I just want to describe a couple. So let's talk about the first one, similarity by functionality enhancement. What does it mean? So the analysts realized that some of the functionality in their app is not very good, or is missing, right? And so instead of finding a product that does everything that their product does, they look at specific products that do that specific thing. And so in that case, they can move and take inspiration for that specific product. Some of the strategies don't particularly work, right? Lazy analysts say, okay, let's write camping into the app. And so you find very generic things, choosing from the very top. But this is also lessons learned, right? If you use not very good strategy, you won't get much. Another strategy is similarity by business mission, right? Summer camp is where you put your kids. Where are your kids are? In school during the year. So why don't you look what a school does? And so in this case, you look into an app that has the same business mission to try to see if you miss something in this new domain. And so this is what we find in this piece. Our second question was, which are the benefits and the challenges here, right? Because this is a very time-consuming activity. Like, you need to go thinking about what to do. And so how did we find this out? We actually, this is the second piece. So the student did the requirements extension after that, and we asked them to reflect about this work. And specifically, we asked them exactly what did you think was good and what did you think was difficult. And after this analysis, we again did the same similar procedure we did for the benefits before, for the strategy before, and we extracted some strategy, and we looked into the literature with a light-based systematic literature review to see also how to compare this what was in the literature. We came out with 5 main groups of benefit and challenges, some related to concept inspiration, some related to requirements inspiration, and some related to the product that, how can you get inspiration for the implementation, right? Because the app in the App Store are actually implemented. And some other about the process, and some other also about what the user wants, because, you have something in the App Store, users are using it. So here are some examples. I just want to show you something. Like, so for instance, people say, you can get inspiration for completely new ideas that you didn't even have because they are there. You chose an app and they may be for business similarity, and then now you find out that you neglected something very important. On the other hand, though, this is a time-consuming activity and not easy, right? Think about looking at the reviews. Reviews can be very polarized, or can be very much empty, or could be very much confusing. And so there are also negative sides. Which are the negative side here? So for instance, people said, you need to be very careful when you do that, right? Because you might find that you are just plagiarizing someone else's app. Or something say, okay, but now I'm finding these new things. How do I bring them in my domain, right? And also, of course, a lot of people say the quality of the review is terrible, there are too many, the process is very cumbersome. So they find a lot of negative things as well. What are the lessons learned, right? That if I have to take these and bring it out, we have strategies, some work and some don't work. And I'm not saying that the one that don't work should be neglected completely, because if we go back to this lexic similarity, maybe you just by chance find something useful, right? But analysts need to be warned about this. And on the other hand, we also need to find what are these benefits and challenges say us. They say us that we might need some support, maybe tools, or maybe guidelines, or maybe teaching to try to exploit the benefits and minimize the challenges, right? Now, this is 12 minutes. So I actually completely neglected a piece of the paper that I encourage you to read. We had a third research question. If you remember in our little box before, I made disappear a box from the very beginning, say, oh, we have a product, right? But actually the student had to do the 2-set round of the interview with the customer and to build their product. And so at the end, we asked them for the differences between these 2 different elicitation techniques. And so we studied that to try to understand how the requirements evolve, right? That was our goal at the very beginning. And to answer our questions about the differences, we collected similar information of the one that I show you also for the interview piece, and then we compare them. It's all in the paper. I don't want to enter very quickly to all of that, but I wanted to make you curious and let you go. So just to finish on time, I want to say something. obviously thank you for your attention, but I want to thank you to other people. Alessio, that coded all of this with me, and actually also our student that is not author of this paper, but was author of our previous work on interview, because he did more than 30-hour interview to have the initial product. So it's a lot of work. Thank you.
Thank you. Okay, do we have any questions? I'm going to...
Thank you. Paola, that was really good. Thank you for that. Just wanted to ask you, what do you think the implications of your current research is over the body of research that's the rest of us together we did on interviews and learning from mistakes and all of that? Like, do you think that this is complementary to what we were doing before, or is it already kind of refuting some of the things that we found out in the previous studies?
I definitely think this is complementary, because if I think about this kind of elicitation, I think that it either complements interviews. So like the most traditional kind of setting, right, is that somebody comes to you and say, oh, I really want to build this, right? And what do? You really have to talk to these people. It's not that if somebody wants something, you say, let me check the App Store, right? And so in this traditional setting, of course, interviews are needed. And so you can use this technique tried to build up on it, right? And then there is this other very different setting in which you have your own company and you have an idea, and then you might start with this, because if it's your own idea, interviews might come in a different setting, and instead of interviewing your customer, you interview users or potential users. Like kind of in the United States, there is a lot of these NSF kind of, I always forget the name, but in which they teach you how to pitch your business idea to users. But in both cases, these are complementary, right? In one case, you do interview and then you do this. In the other case, you do this and then you do interviews to very different people. So.
All right, thank you, Paola, for this great talk. And I think it's really important to go for these hybrid, to research these hybrid strategies, so to say, what you're doing. I have a question to the participants, and I'm not concerned at all that they are students. I think fields like psychology, they are completely based on students and so on. But, and it's great that your participants have a lot of industry experience, or at least significant industry, but you know that industry experience does not mean requirements elicitation experience. Can you comment on this and whether this has had some impact on the results?
So actually those 48% that I mentioned before are exactly the one that actually said that either do some requirements in their current job or have done consulting. So we have the 48% of 80%, so now do the math yourself, those are actually requirements engineer. But the interesting factor is that they are very homogeneous, the result. Because at some point, actually, the career changers goes very close to the more expert one. Because of, I guess, their understanding that they don't understand very much the piece, but they understand the different in context and what it meant for them. That was my, not proven intuition, but the data were very close. So I agreed. But in fact, this data came at the beginning of the year more from a teaching perspective. I asked my students, what do they know already of requirements engineering? And yeah, this is what they know.
Okay, do we have any other questions? Yes.
Thank you very much for very interesting work. I'm curious, do you think that there is a risk that this app store-based approach to getting requirements might limit creativity of developers? So maybe you end up with a bunch of apps that are very similar to each other.
It's actually what some people said. So at the beginning, I had this concept both in benefit and in negative, right? So some people said that when they start seeing what other people were doing, they felt, oh, I need to do that myself. So yes, I do agree. And maybe a solution for this would be, you have these things, try to come out with some idea, and then try to complement them. Or maybe it's always experience the piece that mitigate this piece, but the participants felt that risk themselves as a challenge. So, and it's good that, you saw it yourself and they say it, because then, as I said before, the overall idea of knowing this is that at the end, you can try to find guidelines to mitigate this problem.
Okay, great. Thank you very much for some great work. And
Hi, I'm very honored to give this speech at ICSE conference. Today, I want to talk about some of our work in the field of teaching requirement elicitation. The topic is BARA, a dynamic state-based series game for teaching requirement elicitation. My report has 4 parts. The first part introduces the background and contribution. The second part concerns the specific design of BARA. The third part presents the results of our application of BARA in the software engineering course. The last part is a conclusion. When teaching requirements elicitation, many learners cannot recognize the difficulties in requirements elicitation due to the lack of practical experiments, and thus do not pay enough attention to learn it. Ideally, we want the learners to participate in the requirements elicitation work, interact with stakeholders, and thus can identify the real challenges in requirements elicitation. Because realistic projects and stakeholders are usually not easy to find, especially in university studies, serious games has been identified as an alternative educational approach. Specifically, in a serious game, we can construct simulated requirement scenarios with multiple fictitious characters. A learner can play the role of a requirements analyst and elicit fictitious characters' requirements by interacting with them. The key to making this feasible is that the simulated scenario is realistic enough. The challenger is how to realistically model stakeholders into the game. The existing work is not well done in simulating realistic scenarios. In addition, most of them only provide one scenario, and none of them deeply investigate learners' learning process. First and foremost, the simulation of the scenario is not realistic enough. This manifests as the states of fictitious characters cannot change, which would result in a fixed interaction. In other words, all the characters will always give the same response, no matter how many times the learner interacts with them. This doesn't match reality and cannot effectively help learners to understand and experiment real requirements elicitation scenarios. Instead, we argue that the dynamic state of fictitious characters should be designed and implemented to better reflect the real scenarios. For example, if a learner interacts with a character rapidly, the character will become impatient and thus not respond to the learner. Secondly, most existing work only provide one particular scenario, which is far from enough regarding the teaching objective. In different scenarios, the requirements elicitation experiments may vary greatly. Therefore, providing more high-quality scenarios can cover more situations, allow learners to accumulate more experiments, and achieve better teaching effectiveness. Finally, none of the existing studies deeply investigate learners' learning process. Recording interactions between learners and the game can provide educators with valuable insights into their teaching effectiveness and support a more precise evaluation of learners' performance. In summary, in order to resolve the 3 deficiencies of the existing work, we have done the following work. We design and develop a dynamic state-based series game called BARA, which could realistically simulate real-world scenarios. And we developed an easy-to-use scenario editor to facilitate the process of scenario construction so that non-programmers to construct scenarios. And we also record the learner's action during the game for a more precise evaluation of learners' performance. The second part is the design of BARA. I would like to first introduce the game process of BARA. BARA is same as most 2D role-playing games. A learner can play the role of requirements analyst and is responsible for the requirements elicitation. At a game session beginning, an analyst appears in the scenario, and the learner can control the analyst's role in the scenario. During the exploration, the learner can discover fictitious characters and can either interview and observe with the character. The content of the interview will be automatically recorded for later recording their requirements. Here are the points of the 3 highlights throughout the game process. First, during the game, the state of the fictitious character is dynamic. When the learner interviews with the character again, he may get different information. Second, we design and implement an easy-to-use tool to facilitate the construction of fictitious characters. Third, we record the learner's interactions with BARA for more precise evaluation. I will elaborate on these 3 points in the next 3 subsections. As mentioned earlier, the state of the fictitious character is dynamic. We achieve this by modeling stakeholders with finite state machines. In different states, the character responds differently to the learner interaction, and the state of the character will change under certain conditions. As shown in the figure is a finite state machine of a fictitious character. For example, the current state of this character is busy, and the learner interviews with the character. The dialogue content corresponding to the busy state will be displayed, and after the interview, the character state changed to interrupted. Here is the dynamic state. And we will now move on the scenario editor. We hope to add more high-quality requirement elicitation scenarios to the game. However, taking a pragmatic perspective, it is more important to address the challenges that who and how to produce such scenarios. Although we can step-by-step establish a scenario repository by ourselves, we believe that a crowdsourcing approach would be very helpful and pragmatic. Specifically, we designed and developed an easy-to-use tool to facilitate the process of scenario construction so that non-programmers can easily construct scenarios. On the one hand, we can invite domain experts who are knowledgeable in certain domains to develop realistic scenarios. On the other hand, we can also ask learners to construct scenarios based on their practical investigation to make this process as a part of requirement elicitation teaching. By using this tool, it is easy to create fictitious characters, state machine, and corresponding dialogue content, thereby accelerating constructing scenarios. Let's go back to the game. We also record the learner's actions. Every interaction between the learner and BARA is automatically recorded, such as interview with a character and document a requirement for a character. And each record has a timestamp. This record can provide educators with valuable insights into their teaching effectiveness and support a more precise evaluation of learners' performance. The third part is evaluation. We would like to answer these 2 research questions through this experiment. In order to evaluate BARA, we constructed a library scenario instance. The participants in the experiment are 60 computer science undergraduates. Research question 1 is, what is the quality of requirements written by the learners? Most learners write at least 8 requirements, which shows that they played BARA seriously. Then we check these requirements one by one for identifying unreasonable requirements and found that 80% of the learners identified unreasonable requirements and didn't record them, and only about 3% unreasonable requirements among total of 561. The result shows that the requirements recorded by the learners are qualified, indicating that learners can effectively complete the requirement elicitation task. Research question 2 is, what is the learner's concentration when playing BARA? We remember that we recorded the learner's action. Each record has a timestamp. We calculate the time difference between adjacent actions recorded. If the time difference is more than 300 seconds, we'll consider this is an interruption. We can see that nearly 5 in 6 learners experience BARA with no interruptions or only have 1 interruption, which show that they are focused when playing BARA. The last part is the conclusion. Compared to the existing work, we found that the dynamic state-based design can better simulate real-world requirement elicitation scenarios, and teaching requirement elicitation through serious game can increase learners' interest. This is the end of my report. Thank you for your listening.
Okay, thank you. So we have time for questions. Does anybody have a question? Yep.
Hi, thanks for that. It was really interesting. I'm interested in how you decided the states for the interviewee. So you had busy, interrupted, angry. Was that informed by some prior knowledge? How did you come up with those, the different states?
This is based on the investigation. We first investigation the real person in the library, and we modeled him into the game by create these city machines.
Okay, another question here.
So maybe I didn't understand right, but the student will pick among a set of predefined action, right? Is that correct? So how does the student, you were showing how the student interact with the fictitious character. And so it's in a game, so I'm imagining that the student can do a set of predefined action, right? So my question is there a wrong action that he can do? Because if you give the predefined action, the student will always, cannot make it wrong. So my question is that, are you trying to measure if they are doing well the elicitation? Because then if they are unlucky, they can't. Or you are trying to see if from whatever information they collect, they are able to write requirements?
Thank you for your question. I'll do my best to answer it. Do you mean that the learner could
can you hear me?
Yes, we can hear you.
Oh, okay. Thank you very much. So I was the second author of the paper, and thank you for the very nice question. Basically, based on our design, so in the scenario, so there are some good things and some bad things. And basically, we record all the actions that have taken by the students, and including some correct or expected behavior, and including some unexpected behavior. So the final evaluation will based on all their interactions. Yeah. So I hope this answers the question. Thank you.
So as a follow-up to that, how flexible is it to kind of extend the scenarios and to make kind of more flexible scenarios?
Yeah. Thank you very much for the question. So that is exactly what we want to design in this game. So we want to make that as flexible as possible. So basically, we have a slide that shows that we have an editor, which is designed for practitioners who have knowledge in certain scenario and would be able to easily edit the scenario. So, and currently our plan is that, so the training for students are actually twofold. One is the student will play the game, and so they will gain some experience for sure. And another one is that we will also ask the students to investigate some scenario, and based on the investigation result, so they are supposed to use this editor to make their own scenario and to make their own games. So
okay.
So I'll go back to the question. So we think that would be flexible enough to be useful in our teaching. Thank you.
Okay, great, thank you. Do we have any other questions? So I have one last question. I've been trying not to ask this question through all the other talks, but obviously you started this before ChatGPT came out. Do you think that you would be able to use that now to create much more flexible stakeholders without preparing them with specific information?
Yeah, thanks a lot. So that is exactly a very good question. So we're actually thinking about that. And so one of the things that we have already done is when we planning the dialogue between the characters, so part of them, so we have tried that. So part of them could be assisted by the ChatGPT, but we didn't have a full solution so far. How to fully integrate the power of GPT into the game. But this is definitely a good research direction that we will go in the future.
Okay, thank you. That was a great talk, and thank you for answering all of our questions. So let's give an applause to the speakers, and thanks for joining us.
Is it better? Okay. And I'll be presenting the work we did with an NGO and some challenges we faced. And we tried also to circumvent challenges that are already mentioned in literature. So just to give you a bit of a context, and one nice thing also, let me just get back. This is an interdisciplinary work with people from psychology and design, so it's a very enriching experience for me, who has a background in computer science, and also, well, the second author is from computer science, my colleague George, and the last student, he's also from computer science. And all the rest, they're psychology and design professionals and students. So the context, it's an NGO from Recife, Brazil, our city, and you're 10 minutes already? You're showing me that, so I just have 10 minutes? Is that true? Yes. Already? Presentation, yes. Oh, okay. I thought I had 15, so let's go to the end. Okay. All right. So this institution deals with people who live with HIV and AIDS. Most of the public is people with socially vulnerable background, mostly young people, homosexual men, professionals, sex workers, and mostly trans women. But also they host cisgender women who, because of their partners, now they have HIV. So this is also a sort of a community, a safe place for these cisgender women to have a community to receive them. And there are quite a few challenges with NGOs. Some of them are here, like difficulty finding volunteers that are really committed to the work, getting regular source of funding, and budget for software. Software is necessary for a lot of things. Although there's a lot of free software for doing things, sometimes they need specific stuff for them. So they don't have budget for that. And the idea that we had with them in this project was, well, let's crowdsource the solution. Let's, well, I've been organizing hackathons for 10 years, so everything I think, oh, let's do a hackathon. But it doesn't work like that. There is the work of Mariangelo Ferrario that her team worked with social innovation. And one of the things that she mentioned is that prototypes issued from hackathons, they have a hard time to continue. You need a plan to structure that. And also the process in a hackathon ignores methodologies that have a strong background in social science and ethnographic studies, so they can understand the context of these NGOs. And what we thought is, okay, so let's do a process of open innovation, like to crowdsource these solutions, and social innovation, targeting NGOs. So we thought on 3 phases. I'm going to be talking to you here about the first 2 phases. The third phase is still ongoing. We got some extensions on this project. And basically the first phase was to get an immersion, doing some ethnography to understand this context. So we spent 6 months talking to them and sending the students who went weekly observe the environment, understand what they're doing, understand what are the priorities, because there are quite a few projects in these NGOs, so they wanted to understand which project we could help in this process. So after identifying that, we went into a second phase for co-creation to hire and these solutions through a hackathon. And since this is a context that it's really involves a diverse audience with transgender women, there's people of color who are usually the underprivileged in Brazil. And after we had that, so we were thinking about a very inclusive hackathon to both the audiences and that would join as students, for instance, and also the target audience. And there were 2 projects from the NGO that were prioritized, Pastry Kitchen and Welcoming Space. And as a result, we had personas, documents detailing the environment, videos that were built after that for the hackathon. So the second phase, the hackathon, we had these 2 challenges and some other stipends for 6 months to hire the students and continue the project. So we set up a website and we sent calls for enrollment in the hackathon. We did a pre-selection, so not everyone who enrolled was selected. So there are some guidelines for inclusive hackathons that we developed as part of a study from one of our students. And well, she was talking about hackathons that have to be gender inclusive. The organizing team has to be diverse. Inclusive communication, so you can use neutral communication and people could feel welcome. For instance, the badge that we develop would have the pronoun that the person would like to use when talking to them. And make safety visible through codes of conduct, saying that there are rules and you couldn't be, like we do here in the beginning of the event, that there was the ACM code of conduct, so we got specific ones for hackathons, and provide good working conditions. One of the interesting things we got from the reviews that we provided equipment, like computers, for those who don't have computers to participate in that. And then one of the reviewers said, this is a very interesting point because from a rich country, I never thought that would be a problem in a hackathon, like people who don't have these equipments. And the fifth one wouldn't be the case because we wouldn't have trans people, actually we did one, that would be working as a developer in this event. But that wouldn't be the focus. So the hackathon public was mixed teams, IT skilled people, like mostly students, and also the NGO audience participants that are target of the NGO, and also people who work in the NGO. You see the diverse, just a brief idea, the diverse people who were enrolled, those from the top group, the IT skilled people. And the NGO audience, we had 10 people who were not in the graph. But it's a very diverse audience. The mentoring, so one of the guidelines was to have a diverse team. Well, we don't have, like, it's not even half of the team here. We had one trans woman, most of our LGBTQIA students, and people of color also part of the team. And technical mentoring also, and people from the NGO also were mentors. And this is just an idea, like we get training about link canvas, there are people who are working, so on top right-hand side, that was the organizing team, well, mostly the authors there. And we had pitches, there was an opening talk from the NGO coordinator. And so we provided user needs, talking about requirements. There was material that was prepared for these participants, like detailed scenarios, the challenges, personas, videos that they could watch, and also they could talk to stakeholders who are part of the event. So people who are either participants or mentors. Briefly, just to talk about the data collection, we did pre-event questionnaire, post-event questionnaire about specific aspects like those guidelines, if they worked or not. We did some interviews and also participant observation. So some of the highlighted results and facts is that, well, questionnaire answers were mostly positive. You see Q10, 11, and 20, a little bit different from the rest of the picture though. But 10 and 20 and 11 talk about this material we prepared, the videos and the persona stuff. Not everyone used it, but all of the teams used it because they're individual answers. So people in the team who didn't even care about that, they just wanted to do technical stuff. And the tool that we used for ideation and the creative process, not everyone liked it. And another thing interesting, well, it's very dense in terms of data. You can check the article. One trans man was really happy to, for the first time, use the social name that he chose. And he felt a safe space to be called by this name. And also, we observed that NGO participants were mostly like people, instead of mixing with the team, the participants that join the kitchen and they have day-to-day activities there, they were actually working as consultants. When there are technical discussions, they wouldn't be pretty much involved, it would be apart from the team. This is just a quick look in the tool that they used. One of our sponsors, so I'm proud to show you, try to access that. This hackathon was actually possible because of our sponsors. And then some lessons learned, there are many, just have 30 seconds. But one thing very interesting, maybe the most important one about all of those, when you're dealing with transgender people, there are some guidelines also even to collect information. And for instance, we had the trans woman that was responsible for interviewing the other trans woman. So during the interview, we had stuff that was pretty clear that say, she was referring to transgender woman. And she would never say that to me. And so you would always you should try to create an empathy environment to collect that data. So there are pretty interesting findings. I invite you to get the link to check the article, the many interesting findings for doing inclusive hackathons, and I encourage you to look for NGOs in your city to work with them. This is a very transforming work that we can do.
Great, thank you. Okay, so does anybody have any questions? I'm coming down towards Dana because Dana just gave her talk quite related to this, I think, in Chase, right? Do you have anything you'd like to follow up with?
Yeah, so did you get a sense of the quality of the products that the code that they built in terms of inclusiveness of their end users?
Yeah, that's a very good question. Actually, well, since there are so many aspects to cover, I didn't talk about the resulting projects. There are 2 winning projects, 1 for each category. They were thinking about the external audience to attract them to buy products from the kitchen, for instance. So we didn't see much of that inclusion in that aspect. It's a good question because it was made in a rush, the prototype. Actually, a hackathon that was made for prototypes. There was not much code, but this is an interesting aspect to check on the product they're developing now. So thanks for the question.
Does anybody have any other another question for our speaker? So, first of all, this is a really exciting project that you did, and it's obviously a huge commitment to go and immerse yourself for 6 months. How much of that time was, spent kind of developing versus eliciting requirements, or was it kind of, basically all done kind of incrementally throughout that time?
No, it was mostly, there was no development because we would outsource that after the 6 months.
Okay, so that was like all through Hackathon.
Yeah,
then,
and this is not continuous 6 months that we were every day over there. Yeah. We did a meeting in December 2021, I think. Yeah, 21. Like a round conversation that took a whole morning to understand what they do, who are the key personnel, and then we started contacting, understanding which projects were important, and then we started realizing, then we sent students that would go there almost every day. They spent a few hours. They had access to documents to understand who is the public to profile, the level of education that they have, and so they could build the personas that are part of the generalization of this user that it's part of this community. So there was step by step, and then we ended up with a set of, I would say, resources, guiding resources for the hackathon. That would be basically requirements, users' needs.
Okay, great, thank you. Thank you. I think we're out of time, so thank you very much for a great talk.
Thank you.
Yes.
This way. So this is the work that we did within the context of a project which we were working on with our city council in the city of Bristol, and as it happens, also with an NGO on energy transition. So the challenge that we're facing is that if we are to transition to clean energy systems, we need to change the way that energy is generated and used within the households as well. So what we are looking here is actually working on a case study to understand how we can put this kind of new type of energy systems into the houses. And the focus initially of this work was on digital energy services development, but ended up with kind of new methodological perspective on requirements engineering. Having trouble with a clicker. So the context of the case study itself is about demand-side energy management. So how it works is that we have, the grid which supplies the energy, and we know that there are some peak demand times, like when everybody comes from work, they start using electricity at the same time, and then, if we use renewable-based generation at that particular time, there is more demand than there is available generation, right? So with demand-side response, then you can send stop consumption request to the devices which are not currently in high priority of use. For example, your washing machine, it can be paused until the time when the high demand passes, and then your devices get a signal to continue using. They continue doing their service provision. So that's simple enough. And why we were working on this case study, the first question was, how do we develop this kind of services? And I'm not going to talk about that very much because it's functional requirements and we know how to do that. And the second one was caused by the fact that some such systems have already been deployed and there is a very poor uptake of them. So the council was saying, well, what should we do so that people actually use this thing when we put them into the houses? And that's where we really, this particular talk is focused about. So, so to address this challenge of developing the system and then understand how are we going to be making sure that people like to use this system, we did a number of things, started with literature review and piloted a study on of questionnaire to understand what kind of requirements do we need. And I'm not going to talk about any of that in detail, but we did then a substantial interview-based data collection. And we used that interview-based data collection to both construct the use cases with functionality, but also to do grounded theory-based analysis to understand the adoption requirements. So what are the key issues around the adoption that are surfacing from the data that were collected in the interview study. And so once we had identified a set of categories through this grounded theory analysis, we then did two co-design workshops in order to validate our findings with potential intended users of this system. So I'm not sure how many people are actually using grounded theory, but the key point in the grounded theory analysis, and I'm going to skip that because this is a use case-based analysis, is to really start from the data that you've collected and without any preconceptions start to categorizing this data in order to find out what is actually emerging from it, rather than to start with a preconception like, for example, in thematic analysis, you might say, I'm interested in these topics. While as in here, you start from ground up, you start from the data that you have collected, and you start finding out what's actually the data telling you about what are the issues which are discussed in this data set. So, like, for example, we have something saying that, somebody is using the washing machine, and they are going to be talking about issues related to how full the machine is going to be before they start using it. And then you can categorize it into bigger categories and say, actually this is about how full a washing machine is, but that belongs to the larger notion of appliances. And then after you have collected a number of these kind of basic concepts, then you start understanding what are the relationships between these the concepts. For example, if you're talking about, in this example, we're talking about the data that is collected, then you see that there is a relationship between how people are providing the data and how are they talking about the issues related to the ownership of data and their concerns about it, but also about willingness to share it for a particular set of purposes. And so based on these interrelationships between the data categories, the next, and this is primarily what requirements engineering normally stops. Then we say, so we have categorized these things, we have learned that these things are important. And this is an important step, of course, this is an important thing to do, because we kind of identify a set of patterns. But the power of grounded theory is that it allows you to then step back from these categories and say, so what is actually the bigger picture, what's happening in here? In our case, we understand that there is a set of things which are related to appliances which are sharing data, or people are worried about the data. So, okay, so this is all relevant, all important. But what is the bigger issue around adoption of appliances that we can learn from here? And quite unexpectedly, because we were not looking at this, but the data was talking about things related to, actually, I am giving my things in for you as a service provider to be using. So you're using my appliances, or you are expecting me to change my appliance and my damn washing machine cannot participate in this. I need to get new washing machine. So this is an investment from my side. And, or I am going to have to spend all this time learning how to use this new type of energy management system. So that's time commitment from my side. So very unexpectedly, the new type of kind of perspective that built itself up from ground up in this study was that there is a theory of partnership. So we don't actually talk about this normally when you say service provider, customer. Actually, the customers are in this case seeing themselves as partners in this kind of enterprise of service provision, because they have to provide their own appliances, they have to change the way that they do their daily tasks, their routines. And that's not an easy thing to say, right, to do, because you have to have a commitment to that. So we're asking quite a lot, and they are not customers. They see themselves as partners. So why is it not getting, the normal kind of setup doesn't get a wider adoption? Because if the service provider is looking at you as a customer, while you think you are a partner in this enterprise, then you're not interested in this, provision of service in which you think you're contributing more than you're getting back into. And so that is the theory that kind of derived itself from our grounded theory analysis. And so, okay, all well and good, but then once we have identified the theory, we really came up with another kind of a find that actually, once you have the theory comes not just by itself, but with a bag of new additional requirements that come up because now you are aware about this theory. Right, so now if you know that your customers are actually seeing themselves as partners, you are thinking about, well, what does it mean in terms of my software development? If they are partners, how do I set up this software so that they can participate as partners? And so the theory itself comes up with additional set of requirements, and more interestingly, with the grounded theory analysis, once you have done your data collection, your theory building, your requirements derivation, actually there is a continuous cycle of additional analysis, additional theory building, and additional refinement that you can go through to elaborate and get additional new requirements continuously. So just to kind of focus on what kind of lessons do we learn from here as a summary, is that once we have derived this theory from grounded theory analysis, that theory itself will act as an engine for new set of requirements generation. Like, for example, in our case, we said we are developing this demand response technology, and actually we ended up with requirements for implementing a completely different business model for this software system. The theory and the requirements are also interdependent, because once you start putting these requirements into your software, they in addition actually change additional, bring additional perspectives and additional new perspective to this theory. And that's why I talk about cyclical evolution of this perspective as well. And finally, when we take a step a little bit back and think about it a little further from our case study, we see that actually every time you define a theory and you bring the requirements from the theory into your engineering process, you take one step closer to the complexity of realities. And so this work was published in RE in 2020, and then we had a paper, extension paper to this in Requirements Engineering Journal, which took a second iteration, a new theory derivation. And the point being that the more you do this, the more realistically you reflect the complexities of the real world in your requirement specification. And that's what I wanted to say. Thank you.
Thank you. Okay, Waleed.
Thank you, Rosanna, for the nice talk. And thanks for highlighting that this is actually an RE paper. I missed this in the introduction. This is part of the showcase initiative. My question is, so I had some experience with the requirements elicitation and requirements development, whatever you want to call it, and also some experience with theory, ground theory building, ground theory. And I see one issue that I see is that in requirements engineering, requirements elicitation, one of the biggest challenges is that basically there is no resources to do this. There are no requirements engineers in practice. There is no people that are skilled. There's basically zero resources. And on the other hand, grounded theory is very resource intensive. It costs a lot of time to do. If you do want to do it really right, it costs a lot of time and a lot of effort. So how can you comment on this? I mean, how can we go to a company and convince them that now we need like 3 or 4 people really full time to do this?
Yes, that's very, very valid question indeed. And that is one of the reasons that I talk about interview-based data collection and deriving the functional requirements alongside with theory building. So it is going to be more resource intensive, and that's also one of the points that is discussed in the paper, that you need to be quite certain that the effort that you're putting there is worth, because you do need to do additional work. As opposed to the traditional grounded theory, in which you are really committing yourself to this very deep analysis from ground up, the method that we have been using was actually using the same data that you do collect from the interviews anyway. You talk to people, you understand what you need to do. So you use that very data. And because you can do iterative analysis, you can continuously, and talking about agile development in this case, actually, each of your sprints can be adding that and refining that to your theory derivation process as well. So that's, maybe I didn't mention that during the iteration, but that is one way that you can relatively lightweight include this into the analysis, but it is still an additional work.
Okay, unfortunately, we don't have time for any other questions. Oh, did you have a quick one? No? Okay, we don't have time for any more questions, but thank you for a great talk. So let's congratulate our speaker. Thank you. Okay, and our final talk today is on automated question answering for improved understanding of compliance requirements, a multi-document study, and it's being presented by Sallam.
Yeah, hello everyone. So last but not least, we will finish by yet again another work on question answering. Given the hype that we have seen for ChatGPT, I think it makes sense. But we will have a different context where we use this work. And this is again a showcase paper which was published in RE. So before we dive deep in the presentation, let me give you some context. The work that I will be presenting today has been conducted within a larger project in collaboration with SCL, the government agency responsible for publishing Luxembourg's legislation and administrative procedures. Where in that project we worked mainly on semantic metadata extraction. We have had several publications. The one that I will be presenting today was published in the IEEE RE conference in 2022, and for which we have received the Best Paper Award. We had a follow-up paper describing the details of the resulting tool, Coreka, which was published in ESIC FSE in 2022. So what is the problem that we are trying to address in this talk? With the current advances in information technologies and digitization, new regulations are being continuously introduced and enforced to ensure the protection of personal data, provide guarantees to consumers, and meet certification requirements. Organizations as well as software systems are subject to compliance with applicable laws. Violating regulations can lead to serious consequences, including large fines and the loss of business reputation. So to build a compliant software system, it is now the responsibility of requirements engineers to specify explicit compliance requirements, or are also called legal requirements, depending on the application context. And to do that, they might need to navigate through regulations to extract information that is relevant to compliance. Given that the regulations are often long, ambiguous, contain legal jargons, complex language structures, and cross-references, simply navigating through the regulation becomes an overwhelming task for engineers, in particular when accessibility to legal experts is limited. So what if there is this magic that enables engineers to simply type in some questions related to the context of software using plain natural language? Take GDPR as an example. For those who don't know GDPR is the European benchmark for data protection and privacy regulations, which can affect not only organizations inside Europe, but also organizations outside Europe. GDPR has 88 pages containing 173 recitals and 99 articles divided into 11 chapters. So for example, GDPR compliant software should properly address, among other things, personal data breach, sharing personal data with third parties, and implementing procedures to ensure that individuals have their rights on their personal data. And information about such concerns can be found in different articles in GDPR. So with this magic, the engineer can simply pose questions on GDPR and get the compliance-related information that can be incorporated in the software development. And as you can imagine, this magic is nothing more than a question-answering system, which we built in our work, and I will show you in the next slides how we did that. The recipe for creating such a magic is, as we know, a little bit of artificial intelligence, always needed, a data set that is collectively curated by a legal expert and a requirements engineer, and in this case, it's very important to have such legal expertise incorporated, integrated in creating the data set. Also covering multiple regulations from different domains, and a scoring procedure that helps us assess how good the question answering system is. So in our work, we developed a question answering system where we applied recent natural language processing technologies, specifically pre-trained language models, not ChatGPT, but other ones. And our approach aims to assist requirements engineers in efficiently retrieving compliance-related information from regulation based on which requirements, compliance requirements or legal requirements can be specified. This is an overview of our approach. It takes as input a question that is posed in natural language and a regulatory document. The approach is composed of 3 main steps that I will explain later, and the output is then a list of text fragments from the regulatory document that provide relevant information based on the question and where the likely answer to the question is also highlighted. So in the first step of our approach, we pre-process both the question and the regulatory document. Specifically, we apply a simple natural language processing pipeline composed of tokenization and sentence splitting, just to split the text into different sentences. And similar to the work that was presented earlier, we automatically partition the input document into a list of what we call context spans. A context span in this case is consecutive text with a minimum size of 512 tokens. And this size limit comes from the natural language processing technologies that we apply later on to extract the answer. In the second step, we assess the relevance between each context span and the input question. And to do so, we experimented with 2 different methods, each of which takes a context span and a question as input and returns a score between 0 and 1. Following this, each context span will be assigned a score, which indicates how relevant this span is to the input question. The first method that we use is based on TF-IDF, which measures the similarity according to the frequency of terms occurring in the context span and the input question. And the second method applies BERT cross-encoder-based similarity metric, which computes the semantic similarity. We use the resulting score to rank the context spans according to their relevance, and then we select the top K spans. K is left as a free parameter that can be set up by the engineer according to the practical context and the time budget for reviewing the results. In the last step, we apply a question answering model that is trained to solve reading comprehension task. So given a context span and a question, the question answering model finds the likely answer in the context span. In this step, we experimented with different language models that are already fine-tuned for question answering tasks, including BERT, Albert, Roberta, and Electra. And each selected context span from the top K from the previous step is then fed together with the input question to these language models, and the model then extracts the likely answer. So, but how does this really works in practice? To illustrate, consider an example company, Nord Ltd, which offers subscriptions to music streaming through an online platform. Any system that is deployed by this company is subject to compliance with the European Directive for regulations on the supply of digital content and digital services. And this directive grants the consumer the right to unsubscribe at any time. As part of specifying the requirements of the payment module, for example, applied in this digital platform, the requirements engineer must explicitly specify compliance requirements to address this consumer right. So using our approach, the requirements engineer can look for relevant information by simply posing the question concerning reimbursement, and the relevant context span to the input question helps then the requirements engineer understand that pursuant to Article 18 in this directive, Nord Ltd is obliged to enable pro rata reimbursement to the consumer within 14 days of the cancellation. With this information, the engineer can specify the corresponding compliance requirement as we see on the slide. To develop and evaluate our approach, we use a data set that is jointly curated by a legal expert and a requirements engineer. The data set covers 4 European regulatory documents, including the GDPR and other directives. And in this table, we see the number of context spans generated from each regulatory document, the total number of sentences, and the number of question-answer pairs that are defined on each regulatory document. Using this data set, we assess how well our approach can retrieve the right context span to a question among the top K. And for that, we use recall at K, which was also defined in the first presentation. For K equals 1, 3, and 5. We also assess how accurate the extracted answer is, and for that, we simply use accuracy. We see that BCE clearly outperforms TF-IDF for all K values, and the best performance is achieved at K equals 5. For the answer extraction, Roberta consistently yields the best accuracy. So we built our tool, Coreka, based on these results. And Coreka requires about 34 seconds for answering one question from a regulatory document with about 600 sentences using BCE and Roberta. So our tool is publicly available on Zenodo and is well documented. In summary, we have seen that extracting compliance-related information from regulation is a daunting task for requirements engineers. We created an automated question-answering approach that retrieves relevant context spans from a regulation and extracts the likely answer to a given question. We tested our approach on multiple regulations, and the approach has an accuracy of about 94% in finding the right context span and an accuracy of about 91% for extracting the answer to the input question. With that, I come to the end of the presentation.
Great, thank you. Bashar, you guys at the back. It's more fun running.
Thanks. Thank you, Sallam. That was a great talk, and congratulations belatedly on the Best Paper Award. So I just wanted to get your view on the role of ambiguity in the question answering space here, because even the most mature of regulations are often, when computer scientists start probing them, turn out to be also phrased ambiguously. And I'm wondering if ambiguity was a problem for you, both in terms of formulating questions and the answers, and also maybe finding out some interesting issues with the regulation itself.
To that effect, we know that due to ambiguity, some questions would have different answers that are relevant to that question that can appear in different sections of the regulation. So it served to our advantage rather than disadvantage in this case, because for one question, we can get multiple different relevant information that serve give the meaning that, or the relevant information to the requirements engineer. Of course, this is still, we know that regulation adds a level of complexity related to ambiguity, and we know that regulation is still subject to interpretation. This is why I said that dataset needs the legal expertise to build, because it's not only the requirements engineer that has to say which context is relevant to a question.
Did you by any chance find anything interesting with GDPR? Was ambiguous? Just curious.
Not that I know. No, I mean,
because a lot of laws are ambiguous. I don't know by design, but at least they're almost certainly ambiguous. So I mean, the lawyers also adding an interpretation. It's not that they have a particular, authority to do that. They're just giving you their own personal perspectives on the law.
And all of these interpretations are correct. So this is why it's like it adds a flexibility to have multiple interpretations, which are often always correct, depending on the context, right?
That sounds like a fantastic title for the next paper.
And actually, just building on that, because question and answering is very similar to traceability. It's a form of traceability, but we found that in traceability, the times that things go wrong is when there are conditional statements, and this level, like BERT, etc., is not currently well able to kind of understand conditions and things. I don't know if you looked at that at all.
Yeah, well, I don't believe that language models alone can help in traceability in that case. So there are, we have different other publications related to tracing regulatory statements to privacy policy, for example, or requirement specifications. And we know that language models alone don't have the rights. The interpretation is really difficult, and the similarity within the same regulation also causes confusion to the language model. So we need to have a hybrid method that incorporates different technologies, not only language models.
Okay, thank you. I think probably the last question. I forgot my...
Oh, just a quick question. So I've been talking to a lot to consumer advocacy groups and looking at services and products in general. So I'm just wondering whether you're considering to apply this technique, this approach for other products and services than just software in terms of compliance, regulatory compliance, because obviously regulatory compliance is an important aspect of many of products and services in general.
Yes, I mean, this is, of course, a very good point. We barely scratched the surface, both of the technology that is applied for question answering, but also the application context where this can be useful. So, of course, we would like to extend this work. Yes, okay, perfect.
Okay, so let's give a thanks to our speaker. And I know everyone's going to lunch, but I think that those were some really good presentations, great papers, and as the speakers have pointed out, some of them were, first published here at ICSE, and some of them are part of the showcase where they were presented at previous conferences. So I think that made a really nice collection of requirements engineering papers. So thanks for coming to the session. Have a nice lunch.